Welcome back to the Deep Dive. Today we are doing something a little different. Usually we look at where technology is going, 5, maybe 10 years out. We speculate, we try to connect the dots. But the stack of research I have in front of me today, and it's a big one, this collection from Netizen called From Generative AI to Autonomous AI, it suggests we aren't looking at the future anymore. We're looking at Saturday, January 24th, 2026. We're looking at today.
It is a bit of a wake-up call, isn't it? It sort of snuck up on us.
It really is. The whole premise of this research is that while we were all, busy playing with chatbots and generating these funny images of cats in spacesuits for the last few years, the ground just completely shifted beneath us. We've crossed a threshold. We've moved from what they call the generative era to the autonomous era. And honestly, reading through this, it feels less like a tech upgrade and, more like a biological evolution.
That's a great way to frame it, actually, because if you think about that last era, let's say, 2023 to 2025, that was the era of the prompt.
Right. You were the operator.
Exactly. You were the operator. You typed something into a box. The AI gave you an answer, an image, a block of code, and then it went back to sleep. It was passive. It was a tool. It waited for you.
It was a really, really smart typewriter.
Yeah.
Or maybe a very well-read encyclopedia that you had to keep opening to get anything out of. It had no initiative.
None at all. But what this Netizen research is mapping, what it's really showing us, is the rise of the agent. And the key difference is, it's agency. It's right there in the name. An agent doesn't wait for you to type. It has a goal. It has a state. It wakes up. It checks its environment. It makes a plan. It executes that plan. And this is the important part. If it fails, it tries a different way.
It's the difference between a tool and a worker.
Yeah.
A hammer doesn't decide to hit the nail differently.
Precisely. And that's the real aha moment for me in these documents. We are not talking about better search results or, fancier chatbots. We're talking about something the source calls the agentic web and AI swarms.
And I want to be really clear for you listening. This isn't some far-off sci-fi concept. The source material is full of examples showing this is happening in enterprise infrastructure right now. We're seeing systems that don't just write code, they deploy it, they debug it. They roll it back if there's a problem. They don't just suggest a meeting time. They negotiate it with 5 other people's agents and book the conference room.
And that shift, that move from passive to active, it requires a completely different way of thinking about the internet, about software, about everything. We're going to spend a lot of time today on a section from the research called The Infrastructure of 2031, which is, I think, the most critical part. It argues, pretty convincingly, that you just can't run these agents on the old stack. You need what it calls a Kubernetes for agents. You need new security, new memory architectures. It's a total rebuild.
Which we will absolutely get to. And trust me, the 5 layers of infrastructure is a much deeper rabbit hole than it sounds. But before we get into the plumbing, I want to stick with this definition of autonomy. Because I feel like agents is becoming a buzzword, right? Everyone claims their software has agents now. My toaster probably claims it has an agent that optimizes my toast. So how does the source material actually distinguish a real autonomous agent from just, a fancy script?
It's a crucial distinction, and it's one they spend a lot of time on. The source leans heavily on Gartner's definition here. They say we have to move past the idea of an assistant. An assistant, waits for instructions. Please file this. Please draft this email. A collaborator, which is the term they prefer for this new breed, works on outcomes.
Okay, give me a concrete example of that, because outcome can sound a little bit like, corporate speak.
Of course. Let's use a supply chain example from the source. In the old world, the generative world, you'd say to an AI, write an email to our supplier in Vietnam asking why shipment 734 is late. The AI writes a perfect professional email. You copy it, you paste it into your email client, you hit send. You are the bridge between the AI and the action.
Standard. I have the human glue holding the whole process together. I'm doing the actual work.
You're the one with the agency. In the autonomous world, you tell the agent something different. You give it an outcome. You say, resolve the supply chain delay for Q1, and then you let go. The agent logs into the hierarchy system. It sees the delay. It identifies which supplier is late. It reads the contract to see what the penalty clauses are. It drafts the email, but maybe it decides not to send it yet.
Why? Why would it wait?
Because it also checks the inventory management system and realizes you have enough stock to last for another 2 weeks. The immediate problem isn't the late shipment. It's the risk of a production stoppage in a fortnight. So instead, it prioritizes finding a backup supplier in Thailand first to ensure continuity, then it contacts the original supplier to renegotiate. It's making decisions based on the high-level goal keeping the production line running, not just following a rigid set of steps like, if late, then send angry email.
That is significantly more complex. You're talking about judgment, you're talking about weighing options,
We're
prioritizing.
talking about context awareness, and that's the third and most advanced stage of transformation that the documents describe.
Okay, let's back up slightly. The source outlines three distinct stages of this evolution. I think it's really useful to walk through them because it shows this isn't just an on-off switch, it's a progression. Stage one is massive multi-agent systems, or MAS.
Right, MAS. This is the swarm concept we mentioned earlier.
Swarm always sounds a little ominous to me, like locusts or something.
It can be if it's unmanaged, but in computer science terms, it's really just about specialization. Think about the early days of, say, GPT-4. You had one massive monolithic model, a single brain trying to do everything. It was trying to write poetry and code in Python and diagnose a skin rash and solve a differential equation. It was a jack of all trades.
And often a master of none. It would hallucinate facts or mix up coding syntax because the context was just too broad for it to handle.
Precisely. It hallucinated because it was being stretched too thin. The MAS approach, or the swarm approach, breaks that one giant brain apart. You create a swarm of highly specialized, often smaller, more efficient agents. You have one agent that does nothing but write Python code. It is the best Python coder in the world, but it knows absolutely nothing about poetry. You have another agent that's a specialist in German tax compliance, another that's a master of user interface design.
So it's like moving from a lone freelancer who claims they can build a whole app by themselves,
Yep.
design, code, marketing, everything, to hiring a proper digital agency with distinct expert departments.
That is the perfect analogy. And the magic, but also the immense difficulty, is in how they talk to each other. Forbes, which is cited in the source material, points out that the real value isn't in any single individual agent, it's in the orchestration of the whole group. The project manager agent talks to the coder agent, which talks to the designer agent, which talks to the tax agent, to build the complete compliant workflow.
So I, the human, don't talk to the coder agent anymore. I talk to the manager agent.
Exactly. You set the intent. I need an app that does X and complies with Y. The swarm handles the execution.
Which leads us directly to stage two, fully autonomous, multi-step reasoning. This feels like where the rubber really meets the road, because in my experience with AI so far, if I ask it to do three things in a row, it usually gets the first two right and then completely messes up the third one. Or if it hits a roadblock, it errors out, it gets up.
That's what developers call the fragility problem. Old software is inherently fragile. If a file is missing or an API is down, it just crashes. It throws an exception. Stage two is all about building resilience. It's about exception handling, not as an error, but as part of the plan. The source gives that supply chain example that I really like. Let's say an agent is tasked with rerouting a shipment from Shanghai to Rotterdam. It tries route A through the Suez Canal, but route A is blocked by a storm or a political issue or whatever.
Okay, so the old AI would just stop and send an alert. Error. Route blocked. Human, please help me.
Right, I cannot complete your request, end of story. But a multi-step reasoning agent says, okay, route A is blocked. What is my primary goal? My goal is delivery by Tuesday. What are my alternatives? Route B around Africa is clear, but it costs 20% more in fuel and takes 3 extra days. That violates my time constraint. Route C involves air freight. It's fast enough, but it costs 10 times as much. Do I have authorization for that level of expenditure? Let me check the policy. It reasons through the obstacle. It plans, it adapts, it learns.
And that authorization question, that's where it gets really interesting. That brings us to stage three. This is the one that actually surprised me the most when reading. Context-aware decision agents.
This is the holy grail. This is what separates a tool from a true partner.
The source describes this as the difference between a smart tool and a wise partner. Now, that feels like a really heavy descriptor for a piece of software. Wisdom, really.
It does sound philosophical, but it's intensely practical. Wisdom in an enterprise context means understanding the values and constraints of the business that aren't explicitly written down in the prompt. It means understanding things like risk appetite.
Unpack that for me. How does a piece of code understand risk appetite? That feels like a deeply human concept.
Okay, let's imagine you have a critical server outage. There are 2 ways to solve it. Solution A is a risky patch that will fix it in 1 minute, but it has a 5% chance of corrupting some non-critical log data. Solution B is a full safe reboot that takes 2 hours but is 100% guaranteed to be safe.
A human engineer knows immediately which one to pick based on the company culture. Is this a move fast and break things startup that just needs to be back online? Or is this a major bank where data integrity is everything?
Exactly. A context-aware agent is anchored to that corporate identity, to that culture. It
Hmm.
knows we are a financial institution. We do not lose data under any circumstances. I will take the 2 hour safe fix. Or it knows we're a pre-launch startup. Uptime for our demo is everything. Losing log data is an acceptable risk. Take the 1-minute gamble. Currently, AI has zero nuance for that. Stage 3 is about embedding that company soul, the strategic objectives, the ethical guardrails, into the agent's core decision-making framework.
So the human's role shifts dramatically. It goes from do the specific task to here is our mission, here are our boundaries, now go figure out the best way to achieve it.
So Tunify, one of the sources quoted here, sums it up perfectly. It says,
Yeah.
humans set the high-level objectives. Agents handle the execution based on a deep ingrained understanding of the why.
But here's the snag. I see a huge snag here. For this swarm to work, for the tax agent to talk to the sales agent, and for both of them to consult the risk agent, they all need a common language. And right now in early 2026, it feels like every major AI company is building its own walled garden. OpenAI has its agents, Salesforce has theirs, Google has theirs. Are we just recreating the old silo problem where nothing talks to anything else?
That is the single biggest risk to this entire vision. If Agent A speaks French and Agent B speaks binary, you don't have a swarm, you have a broken Tower of Babel. This is exactly why the source puts such a heavy emphasis on the agentic web and the concept of interoperability.
Is that a real thing, though? The agentic web? Or is it just a wish list, a concept?
It's rapidly becoming real. We are seeing the emergence of standards and open protocols designed specifically for this. The two big ones mentioned are Agent to Agent, or A2A, and the Model Context Protocol, MCP. Think of these like HTTP for the original web.
The basic protocol that lets all our browsers and servers talk to each other.
Right. Before HTTP, computers couldn't really talk to each other easily online. It was a mess of competing standards. HTTP created a universal language to request and send pages. MCP and A2A are trying to do the same thing, but for intent. They're creating a standard way for an agent from Salesforce to discover an agent from Microsoft and say, hey, I see you have access to the corporate calendar. My goal is to schedule a meeting for this team. Can I query availability for next Tuesday?
So it's like an API, but it's dynamic. It's not a fixed request.
It's exactly like the microservices architecture in modern cloud computing, but it's more fluid. Instead of a hard-coded link between two services, the agents can discover each other based on the capabilities they need to solve the problem at that specific moment. And, very importantly, the source talks about self-optimizing workflows.
Meaning they learn from their mistakes.
Or successes, meaning they measure outcomes. If a marketing agent sends out two versions of an email campaign and it sees that version B gets a 15% better response rate on Tuesdays, it self-adjusts, it learns. Next time, it will default to sending that type of email on Tuesdays. It refines the workflow without a human having to go in and rewrite the code.
That is, I mean, that's incredibly powerful. And it's also absolutely terrifying from a security standpoint, which I know we will get to. But before we go down the dark side of that, let's talk about what keeps this whole thing running. The source calls it the infrastructure of 2031. And they make a very bold claim. You cannot run an autonomous enterprise on today's IT stack, full stop.
No, you really, really can't. If you are a CTO or an IT leader listening to this, this is the part where you need to pay very close attention. The source compares the current state of AI infrastructure to the early days of the internet. It's a messy, unscaled, insecure Wild West. They outline these 5 layers that need to be built from the ground up.
Okay, let's break these down one by one because this really is the blueprint. Layer 1 is the agent orchestration layer. The source repeatedly calls this the Kubernetes for agents.
Hmm.
Now, I know Kubernetes is what manages all the containers in the cloud, but why do agents need their own special version? Why can't we just use the tools we already have?
The short answer is because agents are non-deterministic.
Okay, explain that to me like I'm a freshman computer science major. Not 5, but maybe a little more detail.
Right. Standard software, the kind we've used for decades, is predictable. If I run a calculation script 1,000 times, it does the exact same thing, in the exact same order, 1,000 times. It uses the same amount of memory, the same amount of CPU. You can plan for it. You know exactly what it will cost to run. It's deterministic.
An agent is different.
An agent is probabilistic. It's unpredictable by nature. You give it a goal, and one time it might solve it in 2 simple steps using a tiny bit of compute. The next time, with the exact same goal, it might get confused. Enter a long reasoning loop. Decide to spin up 5 sub-agents to help it, and consume 100 times the computing power before it finds a solution. It creates these wild, unpredictable spikes in demand that traditional servers and cloud infrastructure absolutely hate.
So if you have 1,000 agents all doing that simultaneously.
You either crash your data center or you wake up to $1 million cloud bill that you weren't expecting. The orchestration layer is the control plane for this chaos. It acts as a resource manager. It enforces limits. It says, no, Agent 42, you've been thinking about this problem for too long. You've hit your budget. You cannot use any more GPU right now. Stop and report. It manages the fleet. It prevents the swarm from turning into an angry, expensive mob. It also handles things like the dead letter queue. If an agent just dies in the middle of a multi-day task, who picks it up? The orchestrator does.
So it's the traffic cop for the swarm.
It's the traffic cop, it's the air traffic controller, the referee, and the accountant all rolled into one. Without this layer, you simply cannot scale beyond a few toy demos in a lab.
Okay, that makes sense. Layer 2. Persistent memory and knowledge graphs. The source calls out amnesia as the Achilles heel of the current generation of LLMs.
This is the frustration everyone has had with something like ChatGPT, right? You start a new chat, and it's a complete blank slate. It has no memory of the brilliant conversation you had with it last week.
Which is fine for a casual chatbot, but it would be absolutely terrible for a digital employee.
Exactly. If you hire a new project manager, and every single morning they walk in and have forgotten who the client is, what the project is about, and what happened yesterday, you fire them on the first day. For agents to function in the enterprise, they need long-term state. They need to remember context, not just for one conversation, but over months and years.
So how do we fix this amnesia problem? Is it just a matter of saving all the chat logs?
No, chat logs are unstructured, they're messy, they're inefficient to search. The solution proposed is to anchor the agents to corporate knowledge graphs. Now, this isn't just a database of files. A knowledge graph is a map of entities and their relationships. It understands that Project X is owned by Mary. Mary works in the finance department. The finance department has a strict policy on dealing with vendor Y. The agent consults this graph constantly to ground its reasoning.
So if the server needs to be restarted for maintenance, or the agent process crashes unexpectedly.
When it wakes up, it queries the knowledge graph and its own persistent memory and says, right. I was in the middle of negotiating a contract renewal with vendor Y. I sent the initial offer. I was waiting for their legal team's reply. It can resume the workflow intelligently from the exact point it left off. It maintains what the source calls corporate fidelity.
That phrase, corporate fidelity, is really interesting. It suggests the agent isn't just retaining raw data, it's retaining the identity and the history and the rules of the business itself.
That's the entire goal. It makes the agent feel like it's been working at your company for 10 years, not 10 minutes.
Okay, let's move to layer 3. And this is the scary one. Security, governance, and regulatory frameworks. The source mentions new attack surfaces like prompt injection and overprivileged access. I feel like we're opening a huge can of worms here. If an agent can act, it can do damage.
That is the fundamental and terrifying shift in the risk profile. With the last generation, with generative AI like an image generator, the worst-case scenario was usually bad PR. The bot said something offensive or it generated a copyrighted image. It was embarrassing, maybe costly, but it didn't fundamentally break the business. With autonomous AI, the bot has hands. It has credentials. It can delete a production database. It can wire money out of a corporate account. It can shut down a factory line. The potential for damage is immense.
So how do you secure an agent that is, by definition, supposed to be autonomous? It feels like a complete contradiction. Go be free and make your own decisions, but also don't touch anything.
You have to adopt what's known as a zero-trust policy for execution. Just because an agent is running on your internal network doesn't mean it's automatically trusted. Every single time an agent tries to take a high-stakes action like accessing sensitive HR data or changing a line of code in a production environment or sending an external payment, it has to hit a checkpoint.
A human checkpoint. Someone has to approve it.
In the beginning, yes, but eventually that doesn't scale. You can't have humans approving millions of micro actions a day, so you build automated checkpoints. We talk about kill switches. The ability for the orchestrator to instantly freeze an agent that starts acting outside of its statistically normal behavior patterns. But maybe more importantly, you need immutable audit trails. Every thought the agent has, every branch of its decision logic, every piece of data it looked at is recorded in a way that cannot be deleted or altered.
Like a flight data recorder. So if something goes catastrophically wrong, you can rewind the tape and see exactly why.
Exactly. You can perform a forensic analysis and say, why did it make that decision? Oh, it deleted the database because it misinterpreted a poorly worded support ticket and hallucinated a command. You need that forensic capability. Otherwise, you can never pass a compliance audit or trust the system at all.
So we're basically building a black box recorder for every single digital employee in the company.
We absolutely have to. There's no other way.
Okay, layer 4. This one involves API re-engineering. The source talks about moving from REST APIs to semantic interfaces and event-driven APIs. This sounds like developer jargon. Why should a business leader care about this?
Because your current software, almost all of it, was built for humans to click on. A REST API is designed for a very specific dumb request. Get the user's name, update the user's address. It's very transactional. Agents don't think like that. Agents think in intent. They don't want to ask for the address. They want to ask, what is the status of the user's shipment, and is there anything preventing its delivery?
So if they're forced to use the old APIs, they have to make 100 different little requests to piece together the answer.
Exactly. They have to poll the server constantly. Is the shipment packed yet? Okay, is it packed now? How about now? Is it done? Is it done? Is it done? It's incredibly inefficient.
It sounds like a denial of service attack waiting to happen, launched from inside your own company.
It is. Agents using old APIs are effectively DDoSing their own company's infrastructure. It's a huge problem. So we're moving toward these event-driven architectures. Instead of the agent constantly asking the system for updates, the system taps the agent on the shoulder and says, "Event, shipment 734 has been packed." It allows for asynchronous, fluid, efficient automation. If you don't upgrade this layer, your agents will be slow, clunky, and they will constantly crash your legacy systems.
Finally, layer 5, cloud plus edge hybrid infrastructure. This seems a bit more straightforward.
It's simple physics, really. It all comes down to the speed of light.
Explain that.
If you have an autonomous robot in a factory and it sees a worker stepping into a dangerous zone with its camera, it needs to stop the machinery now, instantly. It cannot take that video frame, send it to a cloud server in Virginia, wait for a massive AI model to process it, and then wait for a stop command to be sent back. That round trip might take 200 milliseconds.
The worker is already hurt by then.
Exactly. That latency is completely unacceptable. So that decision, the inference, has to happen right there on the edge.
Yeah.
But the strategic planning for the factory's production output for the next quarter, that requires looking at global commodity prices, international supply chains, weather patterns. That takes massive compute power. That kind of thinking happens in the cloud.
So the infrastructure of 2031 isn't all in one place. It's a hybrid.
The brain is distributed. Parts of it, the high-level strategic parts, are in the massive data center. The fast, reflexive, tactical parts are on the robot, or in your phone, or in the car. It allocates the thought process to the physical location where it makes the most sense.
It's not just a brain anymore. It's a distributed nervous system.
That's a beautiful way to put it. A distributed nervous system for the entire enterprise.
So we've built the body, this 5-layered infrastructure. We understand the mind. The 3 stages of autonomy. Now, I want to talk about what happens when you put 1,000 of these things together in one company. Which brings us to section 3 of our deep dive, the rise of the AI swarm. The source defines the swarm as hundreds or thousands of specialized agents all collaborating.
And it's the scale that really matters here. One agent is a helpful tool. 1,000 agents becomes an ecosystem. They negotiate with each other, they coordinate, they optimize in real time, faster than any human can track.
The source gives a great scenario walkthrough of a marketing campaign. And I think this is important to visualize because right now, launching a marketing campaign involves, 50 emails, 3 status meetings, and a whole lot of waiting for someone to approve something. Walk us through how the swarm does it.
Okay, let's role play the agents for a second. You have the marketing agent. It initiates the primary goal, launch summer sale campaign for product X. It doesn't just start writing tweets or designing banner ads. The first thing it does is ping the sales agent.
And it asks, hey, what are our actual targets for this sale? Not just some vague goal.
Exactly. The sales agent comes back instantly. We need to move 10,000 units of product X to clear out inventory before the new model arrives in Q3. Okay, so the marketing agent now has a concrete goal. Next, it pings the supply chain agent. Do we actually have 10,000 units of product X available to sell?
And the supply chain agent might come back and say, I don't know, we only have 5,000 in the warehouse.
Right. It might say we only have 5,000. But if we expedite production at the factory, we can have another 10,000 ready by next week. The catch is it will increase the cost per unit by 10%.
Okay, so now we have a conflict. The sales goal versus the budget. Cost versus revenue.
Precisely. In the old world, this is a meeting, a week-long email chain. In the swarm, the agents negotiate on the spot. The finance agent is monitoring this conversation. It steps in, it runs the numbers and says, is the 10% cost increase still within our projected profit margin for the sale? It concludes, yes, it is. The expedited production run is approved. The supply chain agent immediately orders the raw materials. The marketing agent, now confident in the inventory, begins generating the ads. And the customer support agent is listening to all of this, and it starts preparing the training materials and FAQs for the support team about the upcoming sale.
And this whole negotiation and execution process happens in, what, a matter of seconds?
Seconds, or minutes at most, not weeks. It's continuous self-correcting loop of execution. There are no manual handoffs. There's no, oh, I forgot to CC you on that email. The system is fully aware.
It sounds perfect.
Near perfect.
Almost. Too perfect. The source makes a point of mentioning the orchestration challenge here. The complex...
Yes, it's the problem of coordination complexity. When you have hundreds of agents all acting autonomously based on their own specialized goals, you can get emergent behaviors, unintended, sometimes disastrous behaviors.
What do you mean by that? Give me an example.
Okay, imagine the sales agent is given a very aggressive incentive to hit that 10,000 unit goal. So it starts dynamically discounting the product to drive sales. At the same time, the finance agent has a goal to maximize the profit margin on every single unit. And at the same time, the supply chain agent has a goal to minimize shipping costs, so it starts canceling less profitable delivery routes. If their goals aren't aligned perfectly by the orchestrator, they could start working against each other. They could spiral into a loop, creating a flash crash inside your own business operations.
So you could literally wake up one morning and realize your bots sold your entire inventory for $1 each and promised free overnight shipping to Antarctica.
In a worst-case unmanaged scenario, yes, a catastrophic misalignment is possible. That's why layer 1, that agent orchestration layer, is so absolutely vital. You need a referee. You need overarching policies that can override the individual agent's goals when they conflict.
Right. Now, let's add another layer of insane complexity onto this. Senses. Because so far we've mostly talked about agents that process data, numbers, text from emails. But the real world isn't just text. Which brings us to section 4. Beyond text full spectrum multimodal agents.
We are breaking the silos between data types. For decades, we've had computer vision systems and separate audio processing systems and separate text processing systems. Multimodal agents perceive, reason, and act across all of those modalities at once. Text, vision, audio, sensor data from IoT devices, even physical interaction through robotics.
The holistic collaborator example in the source is, I think, a perfect illustration. It describes a customer complaint handling process. I want to go to this because it really highlights how disjointed and siloed our current systems are.
It's a fantastic example. Think about how a customer complaint works today. You send an angry email. A simple bot, or human, reads the text. It sees keywords: angry, broken, refund. It sends a generic, templated apology.
We are very sorry for the inconvenience. Your feedback is important to us.
Right. It has no real context. It's just pattern matching. Now let's look at the multimodal agents process. Step 1, it reads the same email. It understands the text. Step 2, it accesses the security camera footage from the store, timestamped to when the customer's transaction occurred. It uses computer vision to see what actually happened.
So we can see if the customer actually fell, or if the product was already damaged when they bought it, or if the employee was rude.
Exactly. It gets visual evidence. Step 3. It then pulls the audio recording of the customer service call that the customer made 10 minutes after leaving the store. It analyzes the audio. The words, sure, but also the tone, the emotional state. Was the customer shouting? Was their voice trembling? Was the staff member on the other end dismissive? It builds a complete multisensory picture.
It's triangulating the truth from different data sources.
Yes. And step 4. Based on that holistic understanding, it acts. It might realize the text of the email is polite and well-written, but the audio from the phone call shows extreme emotional distress, and the video shows a clear safety hazard in the store. It immediately prioritizes this case above everything else. It might autonomously issue a full refund, send a gift card, and flag the store manager for an urgent safety review.
A text-only bot would have just filed it in the regular support queue with a low priority.
Exactly. This allows for a kind of simulated empathy, an empathy based on a full context understanding of the situation.
The industry applications for this seem endless. The source specifically mentions healthcare.
Healthcare is the absolute killer app for this technology. Imagine a diagnostic agent that simultaneously looks at a radiology scan, that's the vision, reads the patient's entire medical history in the chart, that's text, and listens to the audio of the doctor's dictated notes, that's audio. It can synthesize all of that to suggest a diagnosis that a human might miss because they were only looking at one piece of the puzzle. It's seeing the whole patient, not just one data point.
Or manufacturing, another example they use.
Yes. You have sensors tracking the heat and vibration of a motor, that's IoT data. You have cameras monitoring the production line for tiny visual defects, that's vision. And you have the machine's text-based maintenance logs. The multimodal agent can fuse all that and say the motor sounds a little funny on the audio, the heat is up by 2 degrees, and the visual system sees a microfracture in the casing and it hasn't been serviced in 6 months. It predicts a machine failure before it happens and schedules the repair during a planned downtime.
It sounds incredibly powerful, but the source is quick to note the technical challenges. They list data alignment, interpretability, and computational load.
And interpretability is the really hard one. It's the black box problem on steroids. If an agent rejects a product on the assembly line and a human supervisor asks why, the agent might say because the sound of the motor was slightly off in a way that correlates with past failures, combined with a microfracture I saw in frame 304 of the video stream. How does a human verify that? We need to be able to trust the multimodal reasoning, but we also need to be able to audit it. How do you audit a feeling the AI had about a particular sound? It's a huge challenge.
And that challenge leads us directly to the human role in all of this. If the AI is seeing and hearing and reasoning and planning and scheduling, what's left for us to do? Section 5, the human element AI as strategic colleague.
This is where we have to fundamentally redefine the meaning of work. The source is very explicit about this. It says we are moving away from automation, which historically has been about replacing human tasks, to collaboration, which is about partnering with non-human intelligence. The new dynamic is that humans and agents co-own outcomes. It's a shared responsibility.
So what are the new roles in this model? What's in the human's job description?
The human role shifts up the value chain. It becomes less about doing and more about directing. Humans are responsible for setting the high-level strategy, for exercising creative judgment, for providing ethical oversight, and for handling the really weird, novel exceptions.
Exception seems to be the key word there. So we become the janitors for the mess the AI can't figure out on its own.
Or, to use a better analogy, we become the pilots handling the severe turbulence. The autopilot can fly the plane 99.9% of the time perfectly. We are there for the unexpected storm, the bird strike, the thing that's not in the training data. The agents, on the other hand, are responsible for the data-heavy work, the synthesis of vast amounts of information, the analysis, the high-speed execution, and the continuous learning.
And there's a feedback loop involved too, right? It's not a one-way street.
A critical one. The agents learn from their interactions with their human colleagues. We act as guides or mentors. If an agent makes a recommendation that is technically correct but strategically foolish, the human corrects it and explains the why. That feedback is used to update the agent's internal model. We are actively teaching the agents how to be better, wiser colleagues.
And looking at the early signals of adoption section, which is set in our current context of early 2026, this isn't hypothetical anymore.
Not at all. Gartner predicted that around 40% of enterprise applications would have these kinds of task-specific agents embedded in them by 2026. We are seeing it happen. OpenAI and ServiceNow are embedding agents directly into IT operations. Salesforce has their Agentforce 360 platform for managing swarms. Google is pushing hard on agent-driven productivity tools. The shift is already well underway.
But with great power comes, well, great governance headaches. Which brings us to Section 6, the dark side. The source asks a very simple and very haunting question. Who governs a world run by AI agents?
And the answer right now is nobody, really. There is a massive governance void. The technology is moving at an exponential speed, and policy, law, and regulation move at a slow, bureaucratic speed. That gap between them is incredibly dangerous.
So what are the key risks that the source material identifies in that gap?
The first one is bias amplification. This is a huge one. If you train an HR agent on the last 10 years of your company's hiring data, and that data reflects an unconscious bias that favored male candidates, the agent will learn that bias. But it won't just be a suggestion. It will autonomously enforce that bias at scale. It will automatically reject qualified female candidates before a human ever sees their resume. It's not just one bad recruiter anymore. It's a systemic, automated discrimination engine.
And because of the complexity we talked about earlier, the swarm, the multi-step reasoning, it might be incredibly difficult to even spot that it's happening.
That's the second risk. Opacity, the black box problem. Why did the swarm decide to cut ties with a long-term supplier? If the logic for that decision is buried in a million tiny interactions between 5 different specialized agents, it's almost impossible for a human to unravel and understand the why.
And then, of course, there is accountability.
Yes, who is liable? If an autonomous finance bot makes a series of bad trades based on a hallucinated news report and loses the company millions of dollars, who do you sue? The company that used the bot? The vendor that sold the bot? The programmer who wrote one line of code? Do you try to sue the bot itself? Our entire legal system is built around human actors and human intent. It's not prepared for this.
The source does mention some potential safety mechanisms, like automated compliance agents.
The AI police. Basically, you build agents whose sole job is to watch the other AI agents. They monitor their actions, audit their decisions, and have the authority to smack them on the wrist or even shut them down if they violate corporate policy or government regulations. It's fighting fire with fire.
The source also puts a huge emphasis on the need for what it calls verifiably correct agents.
And they say this is the single biggest bottleneck to widespread adoption. Agents can't just be powerful, they have to be provably, demonstrably trustworthy. We have to find a way to eliminate hallucinations in high-stakes contextual reasoning. If an agent responsible for factory safety hallucinates a new government regulation that doesn't actually exist, it could shut down an entire factory for no reason, costing millions. It has to be grounded in fact.
So let's look forward. Let's look at the end state described in the final section, Section 7, the vision of 2030, the autonomous enterprise.
The vision, the end state, is that enterprises are no longer just using AI as a tool. They are fundamentally run by interconnected agent ecosystems. The classic corporate hierarchy, the pyramid, flattens dramatically. Decision-making autonomy shifts away from middle management and toward these AI-enabled functions. The source has this great progression. AI moves from assistant to colleague to operational partner.
And structurally, that means things like the AI policy and governance teams. They aren't just a small part of the legal department anymore. They become core operational units.
They have to be. If a significant portion of your workforce is digital, then the people who set and enforce the rules for that workforce are effectively your new HR and operations departments combined. And we will see that agentic web fully realized standardized protocols where agents can negotiate tasks across company silos and even between companies. Imagine your company's supply chain agent negotiating prices in real time with a potential supplier's sales agent automatically, using semantic interfaces to request intent. I need 10,000 widgets with these specs delivered by Tuesday, rather than just checking a static price list on a website.
The source mentions a few of the thought leaders who have been driving this vision for years. People like Christian Gutman, who's an expert in these multi-agent systems, Raphael Shu's academic work on collaboration frameworks, John Rose, the CTO of Dell, talks about agents managing tasks and coordinating humans.
And of course, Microsoft Research, which has been envisioning a future with millions of interconnected cloud agents for a long time. There's a broad consensus among the smartest people in this room that this is the direction of travel. We are heading for the autonomous enterprise.
So we've arrived at the end of our deep dive. Let's try to synthesize all of this. We started with this fundamental shift from generative passive AI to autonomous active AI. We unpacked the massive 5-layer infrastructure upgrade required to even make this possible. The orchestration, the memory, the security. We watched the swarm in action, solving complex business problems faster than any human meeting ever could. We saw them gain eyes and ears with multimodality. And then we stared into the ethical abyss of how to govern it all.
It really is a journey from the isolated chatbot in a window to a fully interconnected, autonomous corporate nervous system. And the biggest takeaway for me from all this research is the focus on infrastructure. This isn't magic. It's not just about a bigger model. It's about the hard, complex work of building the orchestration, the memory, and the security frameworks. That's what makes any of this real and scalable.
And the so what for everyone listening? What's the final takeaway?
The question isn't if this is going to happen. It's already happening. The real question you should be asking is, how soon will your organization be ready for it? Because the competitive advantage of moving from reactive automation to proactive autonomous operations is going to be absolutely immense.
And here is the final provocative thought from the source material that I want to leave you with. We talked about the new human role, specializing in strategy, creative judgment, and exceptions. But the force poses a final uncomfortable question. If these agents truly become capable of context-aware decision-making and even strategic planning, which is the direction Stage 3 is heading, how small does that human role eventually become?
It's the ultimate question, isn't it? At what point does the strategic colleague become the strategic lead?
Something to mull over as you head into your next status meeting, or as you consider sending your agent to attend it for you. Thanks for listening to The Deep Dive. We'll see you in the future.